let's start with isometric plate 1, ISO 1, and we'll move to the top of the page to problem 1. What we would like to do here is go in reverse. We have the 3 given orthographic views, and what we would like to do is to construct the isometric view. To do that, we're simply going to take our measurements from the top, front, and right side and transfer them to the isometric. Before we begin, we look at the object, and from our experience so far, we realize from the front view we have an inclined surface, which means we have a cut across this corner. We see a hidden line here which tells us something is going on behind the surface, and when we project over, we notice that there's a notch and obviously a cutout here. Since there is not a visible line, an object line going across the bottom, we understand that that cut goes all the way from the right side to the left side, or as we see in the right side view, it goes all the way through the object. We can also see that occurring up here in the top view with our hidden lines. So now we simply need to count grids and transfer them to our isometric grid, front, right side, and of course looking down from the top. In transferring measurements, we can't transfer an angle from here to here, but we can transfer corner locations from, for instance, the front view to the isometric view up here. I also noticed from the right side view that the front and the rear of the object are both flush without any cuts. So to draw the front side or the front view of this object, it's going to be 1, 2, 3, 4, 5, 6, 7, or from the corner here 1, 2, 3, 4, 5, 6, 7. So it goes all the way back 1, 2, 3, 4, 1, 2, 3, 4. Here's my top. Now as I move toward the corner of the inclined surface, 1, 2, 3, 1, 2, 3, and on the corner here, 1, 2. So my inclined edge appears right there and then straight down. The rear surface is going to be a reflection of the front surface, and so now I can even take advantage of the isometric grid system. That corner on the rear surface is going to project straight across to here. It's going to be 2 up, and my object starts to look like this. The last thing I want to do is put this cut that goes from the right side to the left side in, to the rear 1 and up and then 2. It's going to be 1, up 1, and over 2. So I'll draw that in. And as I draw the rest of the object, and it's got a little wiggle in it, so we'll take that out. And there's my isometric view. As you look at it, you notice there is one little problem. there's going to be an edge going back here from this corner, and that's the edge that I see there. Notice to get the inclined surface in, I had to locate the corners and then connect those corners. The rest of this notch goes under the object and I can't see it. Typically on an isometric drawing, we do not put our hidden lines in. Now, I'm going to move over a little bit for problem 2, and this one is a little bit different. It's really a box to begin with. I look at the front view, I see that same inclined surface that I had in problem 1, but when I look at the right side, I also see 2 more inclined surfaces. So what I'm going to do, I'm going to sketch in this object as a isometric box so that I can see it a little more clearly. Very light construction lines. And then I'm going to locate my points. The bottom half is just a rectangular box, and it goes up 2. 1, 2. So here's the bottom part. The very top, this point right here, is over 2, and it's all the way at the top, or up 4. 1, 2, 3, 4, over 2. And you'll notice in the top view it goes 1, 2, 3, 1, 2, 3. So that's that top ridge. Now, it goes from here to here, from here to here. So there's my ridge. It's also going to go 1, 2, so it's going to be on top of that other line on this side, so I'm really not going to see it. Now, from this point here, I'll call that point 1, to point 2, and to point 3. If I locate those points, I can draw this inclined surface. I know that that's point 1 already. 2 is right here. So if that's 2, that's point 2, and that's point 3. Now I simply connect those and my isometric is complete. I'm going to move down the sheet to problem 3, and I'm going to approach it like I did problem 2. I'm going to say that I have a rectangular box. In the front view I see an inclined cut, and in the top view I see an inclined cut. So I'm going to start with just my box so that I can get my general shape. Then I'm going to make my cuts. The first cut, 1, 2, 3, 1, 2, 3, and it goes 1, 2 to the front nose, and without worrying about the second cut, that's my first cut drawn in. Now, I have a difficult time locating this cut in the top surface, so I'm simply going to locate this cut here, this slice here, in the bottom edge, and you'll notice it's 1, 2, 1, 2. So this cut is 1, 2, 1, 2. So it hits that surface there, projected up. It hits that surface there, and therefore when I connect across, and my surface looks like that, and the object is completed. I'm going to leave my light construction lines in. I'm not going to worry about erasing them. Now, one of the nice things about graphics is that lines that are parallel remain parallel. In this case, notice that these two lines appear parallel, and so on and so forth as I go through the object. However, this edge and this edge are not parallel, and therefore in the isometric they wind up again not being parallel. Let's work problem 4 to finish this sheet. And I remember from orthographic projection that this surface here is more than likely going to be an oblique cut on the corner. So the rest of the object is a big rectangular prism. I'm going to lightly sketch it in so I can get a sense of the overall shape, and then I'll make that cut on the corner. It's obvious that these two corners are related. I'll call that corner 1, and these two, that'll be 2, and therefore this one, which is 1, 2, 3 back, 1, 2, 3 back, we'll call that corner 3. Now if I can locate my 3 points in the isometric, I can just connect the corners. 2, so that's corner 1. 2 is on the front edge in the right side view. That's the front side, that's the rear side. It's 1 up, that's 2, and 3 is 1 forward from the rear. And there's my cut. I go back and add my visible lines. That one could have been a little bit straighter. And there's my cut. And I probably need to add that little piece of a line there. If this line looks like it's sagging too much, we'll simply take it out. Whoops. And add a straighter line across there. This plate has inclined surfaces, and our very last problem now, that's an oblique surface.